Okay, so number 11 on your momentum and conservation of momentum sheet. So it's a red ball initially going east at 10 meters per second, a blue ball also going east at 4 meters per second. They collide. The blue ball continues in the same direction, 7 meters per second, so 7 meters per second east, and the red one reverses direction and travels 5 meters per second. So velocity of the red final, 5 meters per second, and this is going to be west. Part A of the question wants you to find the mass of the blue ball, so we don't know this. So of course we're going to use energy, momentum, m of the red, v of the red initial, plus m of the blue, v of the blue initial, will equal m of the red, v of the red final, plus m of the blue, v of the blue final. Okay, so in this question, it's the mass of the blue ball we don't know. So take them to the same side. So I'd probably bring this one over here, and I'd bring the red over here. So m red, v red initial, minus m red, v red final will equal m, oops, that's not an m blue, v blue final minus m blue, v blue initial. So just watch your positives and negatives here. We're trying to find the m of the blue, so you're going to factor that out. So m blue brackets v blue f minus v blue I. And on this side it's still m red, v red initial minus m red, v red final. And now to get the mass of the blue by itself, divide by the bracket. So we'll have m blue is equal to m red, v red initial minus m red, v red final divided by v blue final minus v blue initial. Filling in our numbers, the mass of the red ball was 2 kilograms. It was initially going 10 meters per second east, and we'll call east positive, minus 2 kilograms, and its final velocity was 5 meters per second west, so this will be negative 5 meters per second. On the bottom, the final of the blue was 7 meters per second east minus 4 meters per second east, so both negative. So on the top, 20 kilogram meters per second plus 10. So the top is going to be 30 kilogram meters per second, and on the bottom it's going to be 3 meters per second. So the mass of the blue ball is going to be 10 kilograms. Part A, done. Part B says find the initial momentum of the red ball. So the initial momentum of the red ball, P initial red, is equal to the mass of the red times the V red initial. So P initial of the red is equal to 2 kilograms times 10 meters per second. So P initial red is 20 kilogram meters per second east, because that's the direction of the velocity. Part C, the impulse on the red ball. Impulse is J, and since we have M's and V's, we would do J red, VF red, minus VI red. So red, 2 kilograms, VF red, negative 5 meters per second, because it's west, minus 10 meters per second, goes in positive because it's east. So that's minus 15 times 2 is negative 30 kilogram meters per second, where the negative means west. Okay, that is number 11. Number 12, probably don't have enough room in that sheet. Number 12, a space explorer finds himself some distance from the space vehicle with no motion between himself and the vehicle. Okay, so here's Buddy. So he throws a hammer, mass 2 kilograms, away from himself in the direction opposite to the space vehicle. So here's his hammer. Okay, so he's going to throw it this way. in hopes that he will go this way. So he throws the hammer, and the hammer's mass is 2 kilograms, and he throws it at a speed of 15 meters per second. So V hammer is 15 meters per second, and this is V final, because initially they're both 0. So V hammer initial is 0, and V of the dude is 0. So V final of the person is what you're looking for. I think if his mass is 100 kilograms, what is his resulting velocity? So the person's mass, 100 kgs. So M of the person, V of the person initial, plus M of the hammer, V of the hammer initial, will equal M of the person, V of the person final, M of the hammer, V of the hammer final. Neither of them are moving to start with. It's an explosion. We're looking for V of the person, so mine is mass of the person, V of the person final, will equal M of the hammer, V of the hammer final. Divide both sides by the mass of the person. So V of the person final will equal negative M of the hammer, V of the hammer final, M of the person. Hammer was 2 kilograms. Final was 15 meters per second. Mass of the person, 100 kilograms. On the top, negative 30. On the bottom, 100. So V of the person final should be 0.3 meters per second. Whoops, there's a negative there, and that means towards space station, space vehicle, or away or opposite hammer. Right? So it's his way of trying to get back to the space vehicle. Number 13. A stationary bowling ball of unknown mass is hit on by another hard ball of mass 2.5 kilograms moving to the right at 3 meters per second. So here is my bowling ball, and it is stationary. V bowling I is 0. And it says it's hit on with a hard ball, mass of 2.5 kilograms, going to the right 3 meters per second. So V hard initial, 3 meters per second right. After the collision, the 2.5 kilogram ball rebounds, which would be left. So V hard final is 2 meters per second left. And the bowling ball goes to the right, V bowling ball final, 4 meters per second right. And the question, what is the mass? So M of the bowling, V of the bowling initial, M of the hard, V of the hard initial, will equal M of the bowling, V of the bowling final, M of the hard, V of the hard final. Initially, the bowling ball is at rest. You're looking for mass of the bowling ball, so bring this term over. So M of the hard, V of the hard initial, minus M of the hard, V of the hard final, will equal M of the bowling, to get it by itself, divide by V of the bowling final. So M of the bowling ball will equal, the hard ball's mass was 2.5 kilograms. The initial velocity was 3 meters per second to the right, so positive 3, minus 2.5 kilograms, and the final velocity was 2 meters to the left, so negative 2. Divided by the bowling ball's final is 4 meters per second, and it's to the right. So on the top, 7.5 plus 5, so 12.5 kilogram meters per second, divided by 4 meters per second, and you should get a mass of the bowling ball to be 3.125 kilograms. All right, number 13. Oh, that was number 13. Oh, I think I finished all the ones I was supposed to do. I almost kept going. Okay, so now time for you to do 14 and 15.